Hello guys and welcome to Top Channel 101. So today we're going to be making this amazing flower using Blender and geometry nodes. But today I want to start off with an inspiration quote just to motivate you. It's an African proverb that goes, La Kwang el La Kwang intal La Kwang. Now I don't really know what that means because it's in an African language that I don't speak, but you're welcome. Motivated? I'm sure you are. So let's make this flower. So if I wanted to make another flower, I can just draw another curve. I can make this twisted as much as I want, and the end will always have the flower, and the path will also have some leaves, our input, and now I can obviously change the start and end position of this flower, which is amazing. Let's start with a curve so that we have this ability of drawing the flower. So we can go to geometry nodes. Okay, so we have a new geometry setup. Let's create a petal. I'm going to start with a plane. There is no actual planes, but you can use a grid. So under mesh, we're going to get a mesh primitive. We're going to get a grid. Our grid, and the grid is very important here because it has a lot of subdivisions that we can use, and we're going to first look at this. I'm also going to turn on wireframe so that I can see the number of vertices that we have. So let me increase the X and Y vertices. So the shape we're going for is a flower, something in that shape. Okay, so to do that, we're going to use a set position. That's where we can manipulate the position of each of these vertices. And what I'm going to do is grab the position attribute to get a reference for every point we have. And if you look closely, we have each vertex is at an X, Y, Z location. And what we want to do, we want to push all the vertices at the top here closer to the y-axis, and we can maintain the position of these. So we want just a fall-off like this and like that. Now to do that, I'm going to use a combine or a separate. Is it a combine? No, it's a separate XY, so that I get access to separate axes here, and I want to again do a combine. Because we want to manipulate the position of these and then feed them back to the original geometry. So what we want to do is influence the position of each vertex on the x-axis by their y position. So if I just drag the y position directly into the x, you can see that we are basically using the x values, the y values for the x values, and using them in the x values, but we can also add a fall-off to this. So if I use a math node, a float to curve like this, I can instead of just moving this directly into the x-axis, I can create a fall-off and basically just shape this in the shape of the curve that I want. One thing you will note about, I will have to mention about the float curve is that it works in a range of 0 to 1. So anything below 0, which are negative values, are not going to be affected by this, and anything above 1 is not going to be affected by this. So instead, what I'm going to do to make sure that everything is affected, I'm going to make sure that I first offset the grid so that we don't have any negative values. And to do that, I'm just going to get a curve. I'm going to just grab a set position and offset the y values, because remember, we're using the y values here, and since they have some negative values, they're going to be ignored by the float curve, as it has a range of, where can I see the range? You can see the minimum value. You can change this, but it just adds a lot of confusion. I'm just going to leave it as a value of 1 to 0, so that it's much easier to explain. So I'm just going to offset the y values by, I think, 0.5, so we don't have any negative values, and all the values we have now will be affected by by this curve ramp, by this float curve. But you see, what we are having is what we are seeing here is that we are replacing all the values with whatever we are doing here into the y value. We don't want that. We still want to maintain we just want to create an offset to the original values of the x, to the original x values. So what I'm going to do is just multiply whatever we are using here with the x value. So I'm going to use a math node here, and just get this, get that, multiply, and we should have that. Now you can see already that we can shape this like a flower, like that. Like I said, we can use the bulge, this here, to create that bulge, but you see it has a minimum. We can't really, it doesn't affect the vertices here and up here. So to make sure that it gets, those are also made smaller, we can use the x value of the grid to shrink that down, and then we can try to increase the bulge here. But you can see it's not really affecting everything as we want. So what we can do is just increase the factor here by something like 2, and we should get a petal like that. You can even try increasing 4, but you start to experience that issue there. But so keep it to maybe somewhere like that, and then now you can just I can just add another math node here to amplify the effect a bit more. I can reduce now this factor a little bit better. I like that, and we have the petal form at least now. Then the other thing we could do, we need this petal to have an arc like that, and also have a V shape like that. So let's start with the V shape, and then we can add the curve shape. So for the V shape, we just need let me show you. So the V shape is we just need to offset the Z values like that. So I can grab the X value and use them on the Z value. So if I grab this directly into the Z, I get this this going on. If I remove first disable the X offset that we have, you can see that we are getting this tilt, and that's a result of values coming from -1, negative say, let me see, can I write? So the grid is like -2, -1, 0, +1, +2, and so forth, and those are being utilized as the Z values now, as we have as we just connected the X value to the Z value. So if we want to make sure that it doesn't go in the next Z in the negative value, but just bounce or reflect off like that, we just need to change the negative values back to positive values by using the absolute node or absolute value. So if I go to a math node and use the absolute value, that will make sure that all the values we have are positive value. We are having this going on here. That's a result. That's because we don't have enough resolution in the X, but we basically can get that like that. And now if I combine this back with our original X, you can see we get that and that shape like that. The other thing that we might need, another thing we might want is we don't want this to close up at the top here and at the side here. So what I'm going to do, let me see if I can explain this better. If I remove the wireframe, you can see how it's shaping. We want this to be maintained. This V shape or valley shape to be only at the middle, but like you can see in the petal, it doesn't. That V shape doesn't come up to the apex or the end of the leaf here, and it also doesn't start at the beginning here. So what I'm going to do is just use, so we have y values starting from 0, 1, or it's 0, 1, 2, 3, 4, 5 to something, or I think it's 0, 0, 0 0.1, 0 0.2, 0 0.3, something, because this length is about 2 meters, so within that range. And since we have values starting from 0 going up, what we can do to make sure that this doesn't affect the values, the values here, it doesn't create a V here and a V here. We can use that value, the Y value, and just multiply it. Do a multiply with the Y value, multiply with the V values, and then you can use that as the offset. And you can see now we don't have that in the Y anymore, in the Y value, because 0 times any value you will get a 0, meaning that we won't have that V shape here as we are multiplying values here with a 0, making the Z values flat like that. I'm not sure if that is much clear, but I can't think of a better way to explain that. But we still have that value, these values up here. We can try using maybe a curve. So we can try using a curve like that, and basically just create the follow. So we have X values from 0, Y values. Now we have basically changed the range of our Y values, which range from 0 to 2 to something like 0, 1, and then back to 0. So meaning that only the values within the middle are going to be affected, which is exactly what we want. And I think we might, let me see, am I going to negative values? Yeah, we don't want any negative values, so I'm just going to pull this up a bit. Yeah, so we have a leaf like that. Now we need to create the same arc for the Z so that the leaf bends a bit. And to do that, I'm just going to grab, so we already offsetting the Z value, so we need, we can also still use the Y value. And if we bring this Y value directly into the Z value by passing whatever we have done here, you can see what we are getting. We are getting these 0, 0.1, 0.2 up to 2, and translating them into Z values, which is going to shift the mesh up like that. But we can also apply the same fall off so that this range is turned into an arc like that. So I'm just going to grab this, grab the Y values like that, and then down. See what we have done there? Like that. But we are losing the V shape because you remember this is what creates the V shape. So now to combine the V shape with whatever values we have here, we're just going to use a multiply. So if we multiply these values with this, we already should see this happening. It doesn't seem to be. Let's try adding. Yeah, I guess adding would do that. Yeah, it's experimental. I've done this several times, but sometimes I forget and have to rethink of new ways to approach the problem. And if you look at the original file, which I'll be sharing on Patreon for anyone who wants to examine the project file, you see that the original project I am using is going to have might have different approaches to different things than I'm doing here. So don't worry, just find a way that works. That's what the goal should be, and you don't really have to follow the same process all the time. So yeah, we have the flower. Now let's combine it into an actual leaf like that. That is the easiest part. And to do that, let me first remove these nodes and make sure that I'm saving our backup. Ctrl J and call this Petal. But yeah, we have that. We can even set smooth to give it a smooth surface like that. And now we need to turn it into an actual flower. Like I said, that's the easiest part. We just need a mesh circle, and this is going to provide us with the necessary points in a radial form that's how we can instance this on. And if we do a mesh to points, you can see the points we have. So each point is going to instance another point. So we can do instance on points. Just grab this petal we created. Now if we scale this down, you should see that we have a petal for each flower, like that. If I reduce the radius, we get that. The flowers are not facing the right direction. If we get the normal of the normal direction of each of the points, we can use this to create a new rotation for each point. And because normals don't translate directly into rotations, we need to get a line euler to vector, and our vector is going to be the normal. And am I doing this right? Let's see, what am I doing wrong? The reason why this wasn't working is because I was using this mesh to points node, which is converting the mesh data into points, meaning us translating into losing the normal data that we are trying to reference here. So it doesn't exist. That's why this is not working. So immediately, if I mute this, you can see that I will get that rotation back, because we now have the normal information from the mesh. Because at this point, this is no longer a mesh, it's just points. So if I remove this mesh, the conversion from mesh to points, we retain, or we still have that mesh data that is needed for translating the normal into rotation, and you can see what we have. Still, these are not rotated in the right direction. As you can see, these flowers or these petals rotate outside, from inside outside, pointing outside. So that should be an easy fix. All we need to do is rotate them a little bit more, because they are, let me just show you. If I do an euler or rotate vector, I think it's a rotate vector, rotate euler. Yeah, rotate euler will work. Then, so by -90, that should have these rotated outside the way we want. But they are still spread out, so I'm just going to reduce the radius down like that. And you see that we are running into a new problem where these are intersecting or overlapping each other. Now to avoid that, we can try to look at how this mesh is laid out. You can see there is no overlap, because there is some bit of offset in the Z, and we can achieve that by just giving translating these. So if I do a set position after translating the position of these instances in the Z direction, using let's try using some sort of noise. So just randomly translating them up. So let's do a combine. We can do a combine. I want to just add this random noise to the Z, and the noise usually has an offset of 0.5, so we need to subtract that so that everything is back to the center. But you can already see that we are getting we have managed to reduce that overlapping issue. So let's first subtract using a math node the offset that comes with the noise. So I'll do a subtract 0.5, and you can see everything is back to the original point. But we also don't want the noise to be strong, so I'm going to add a math node, a multiply node, to kind of scale down the strength of the noise. We're still seeing some intersecting issues, but we can fix that in a few different ways. Our petals also still look a little bit too thick, so I'm going to come here and just make them a little bit less, and maybe do that. Another thing we could do to try and remove that intersecting, we can try offsetting the position of each petal, or try to rotate the petals a little bit. Let me show you what I mean. So we can use our rotate instances here, and we can use the index of each vertex, and maybe rotate it so if I do, let me just use a combine for the rotation. I can see I want to rotate them. Yeah, actually I don't even need the index. I can just do this. It gives me this is exactly what I wanted to do, but I think it's too much. Might be a bit too much, or maybe our V shape that we created is a bit too much. So let's find that V shape. I can't remember where that is. Is it this? Yeah, it's this. So if we reduce the V shape, and you can see that this doesn't have that big of a V shape. So yeah, that is a cooler. Okay, so can adjust a few of these things. Okay, now let's add the pollen stuff here, this whatever thing is. And for that, I'm just going to use this mesh sample since we already have that data. And yeah, this is, you can also start offsetting, exposing some of these parameters. So example, the Petal parameter, if I wanted to expose it, I can just have that connected to the input node, and now I can just do that. And let's see, what was I trying to do? The pollen. Okay. So the pollen stuff, we can just, like I said, use this circle here and just do because we need it to be filled like here. So I'm just going to do mesh to curve, because I want to use I want to use mesh to curve, because I want to fill this. If you look at this now, it's like this, and I want to fill that into an actual surface, into an actual face. So we need to first convert it to a curve. So I'm going to use again, you have to convert it to a, so it's a mesh, we have to convert it to a curve so that we can use the fill curve option. So fill curve option, and that will fill it. And now I want to add some volume to it, because right now it's a slice or a plane. And to do that, I need to convert it back into a mesh. So I'll just use this mesh to curve to mesh, like that. This step is not necessary, since the fill curve actually converts the curve into a mesh. As you can see that the output here is showing mesh, so that's done for us. And the reason why I want to do this is because I want to create this bulge. If I go in the view here, I want to create this dome. I can't draw with the mouse, but a dome, stuff like that. So I'm going to use an extrude mesh. That gives us an extrusion. We don't need that big of an extrusion, and now we can use a scale element. Yeah, scale element. This will let us scale this surface, but we only want to scale the top face. So I'm going to use the extrude output top to select the top face, and remove the individual faces option. So we have that, and so we getting something like that. So it's not really a dome, but we can make it into a dome by using the subdivision surface function. I'm just going to call them functions nodes, maybe. Okay, something like that, and yeah, we have that. It's not perfect, but it's not going to be too visible as well. And we can also add a set smooth. Like that. And if we bring this and join this using the join geometry node, like that, we get a flower. And yeah, we're also having some gaps between the this and the pollen, or whatever it is called, and the petals. So I'm going to do a scale element, another scale element, which I already have here, and just scale this a little bit like that. Now, at this point, this is where I want to make the flower a little bit more interesting. So I'm going to start working on some materials. Let's slide this and get a shader editor. I'll create 4 materials. So I'll call this the first material is going to be petal, petal flower petal. And to make sure that the petal or the flower petal is actually using that, I'm going to go where are we instancing this. So this is the instance that creates the petal. I'm going to do a set material and select the petal material. Now I can make some edits to the material. So make it should be pink like that. Now we can try making the material look like an actual petal by using, let's say, coordinates, texture coordinates, and separate, because we want to create these lines here, we're going to use a separate. Do we even need that? Let's try a noise texture. Noise texture like this. If we preview this, you will see that the noise is stretched in this direction, which is actually amazing. So if I do a Ctrl T and try to stretch this or try to move this in the X direction, it's rotating. If we try to move this in the Y direction, you can see that it's going in the direction of the petal, which is nice. So that means I can stretch this in the X direction, in the Y direction, and probably have this stretching as well. And I think I can also might need to stretch it a bit in the Z direction so that we get those lines. Very, very convenient. Now we can now use our color ramp and just make the colors any way you want. What I also did is grab another noise texture. Could have used this, but yeah, just blended the two so that I have some bit of noise in there, just like that. And I use this as the roughness and the base color. And I also use some translucence for this, so like that, and we are good to go. We are good to go, are we? Let's compiling shaders, and like that, that should be okay. You can also use these as bump maps. So I will just do a bump. I'll search for a bump node here. Connect this to the height, and we should be good to go. Let me bring back my reference image. Reference image. Let me pin it. So we have something like that. I'm going to reduce the something like that. If we go to cycles, change the render engine here, turn on denoise, and GPU sky texture. Look at that, a flower. Now we can. Now, don't forget this is procedure, so I can increase the number of petals just like that. Another thing I added in the material is I just added an object info node to get some randomness in the colors. So if I sample the random output of the object info, I can basically just add in some randomization in the color. Just blend the two. Just set this as the color. I'll set the blend mode to color like that. I'll use this for the translucent and base. And now we can introduce a little bit of randomness in these And if you want, you can also add another mix node here and use a value if you want to make it a bit more darker. But I think I prefer the... Why is this color is not as deep? Oh, I think that has to do with the how we are mixing these. Yeah, you can play with the materials as you want. Get maybe these should also be a bit deep, maybe dry overlay. That usually makes the colors more saturated, like that. Yeah, much better. Yeah, I think that looks good. Okay, so let's create these, whatever these are, pollen grains. Oh, yeah, pollen grain, I think that's what they're called. Let's come in here. Yeah. Okay, so to add pollen here, since we have this mesh already, which I can show you here. Okay, this, we can instance these polygons, and I don't want to use something heavy. I'm just going to grab a mesh primitive cone, which looks like that. We don't need that many vertices. We can probably get away with 3. Scale this down. Maybe even add a subdivision, because I don't want it to be that pointy. I can use a subdivision surface like that. Maybe increase the base a bit and reduce the depth. That's going to be our cone. Maybe play with the top radius. That's going to be our grain. So now we just need to instance it onto this surface. So since we already have the surface, we can use our distribute points. If I can type distribute points on faces, use this as the mesh. If we look at this, we have one face. I'm going to increase the density to maybe 1,000. Okay, that's too much. 100. 1,000 like that, and we can do now instance on points like that, and now this is going to be our grain. Is going to be our instance. It's too large, so we can reduce the scale of that. Maybe we need 2,000. It's okay. 5,000. 10,000. It depends on what you want. Like that, and we still need this to be. We still need the original, so we can connect this, and we have the pollen. I'm going to increase the size like this, so maybe I can reduce this by half. Maybe let's see. Can I double the segments here? Just do. Now we have a lot to do, so let's jump into the materials. So I'm going to create a pollen material. I'll just call this pollen. Maybe, I don't know if that's the spelling. And I'm going to use a set material and use the pollen material there. And this, we're going to use the same trick. So use our texture coordinates like this. Do a separate XY using the generated. This should also give us a gradient, up gradient like that. Can use a car ramp, because if you look closely, you see that the pollen has that yellow stuff at the top, so we can create a mask for that like that. And I'm going to also grab a noise texture like this, blend the two, and I think I'm going to use a darken at the darken option And I can also grab another color ramp here. So that's going to be our pollen, and we can just grab another color ramp to colorize this whole thing. So the white area is going to be the orange or yellow bit, and the black area is going to be the purple stuff, purple like that. Now I can connect this to the base. Like that. We also need to set smooth for this because I'm seeing facets. So set smooth like that. Maybe use this as a bump detail as well. So use this as a bump detail. 2 again. Okay, so we have the petals. Let's see, what else do we need? Okay, one other thing I could do, if we go back to the original flower, you can see we have a few extra details. We have 2 layers of petals and then this green one. So we can do that quite easily. I'm just going to grab, let me expand this. So these are our, where are they? These, where? Where? Yeah, these are our petals, the first petal. You can easily get a second layer of these. Maybe we can first make these a bit wider, thicker, and reduce the number of petals we have. So that's actually, I think we don't need to export this just yet. So we can grab a group like that. Yeah, okay. I see. Yeah, have this. Do a transform of these. This is going to help us to duplicate these nodes and rotate them as well. So I'm going to join this back to this. And just rotate them a bit like that, and then move them slightly above and scale them something like that. Yeah, then for the green one, we can also do the same process. Basically just get a transform node like this, push these, push these down and scale them a little bit more like that, and just give them a different set material and just change the material a bit, just like that. So I think I'm going to end this video here. I'll be continuing this with part 2, so we can see how we can make this functionality of adding the stalk and then these extra leaves and this thing here. I can't remember how it's called, but yeah, thank you for watching. I'll see you in the next video.